good evening, good morning, good evening, everyone. Welcome to another episode of Xah Talk Show. I am actually half drunk. Okay, but anyway, we are going to code Wolfram Language graphics programming on geometry, about plane curves, mathematics. Okay. So I'm actually half drunk because I've been drinking red wine, not much, 300 milliliters. That's I'm not a drinker. Anyway, so my keyboard, this is Ultimate Hacking Keyboard UHK80. I have a review on YouTube, and this is Nulea Trackball, Nulea. And that's Logitech Logitech mouse. So okay, so this is Nulea Trackball. So what is the model number? Let's see. M505. Okay, I have a review on YouTube and also on my website xahlee.info. And this trackball, you are mostly familiar. I think everyone. This is so classic. This is Logitech G502, okay? Show it. Come on, show it clearly. Stupid camera. Okay, G502. The best thing about G502 Logitech is the spin wheel, infinite spin. Okay, anyway, so let me show you my screen. Infinite screen, okay? Infinite spin. That's the best thing about the Logitech wheel. Anyway, so we are going to code Wolfram language graphics programming on caustic. So this is part 2. So I begin, so you can watch my last video about 3 days ago. And anyway, so today is Xah Talk Show episode 778. So before that, it's 777 episode. So in that episode, you can watch it. Anyway, so today we're gonna continue to write the code for the. Let me show you. Okay, for the Nephroid curve, this curve. And we are going to create the code for generating the caustics, catacaustic of a circle of cardioid, which is nephroid. Okay, you probably confused. Like what does that mean? Like what the fuck does that mean? Let me explain. Okay. Anyway, I'm kind of half drunk. Okay, so if you are here, say hi. If you are watching offline, play at 1.5 speed. And, I don't know if this is useful to you. This is just gonna me doing my live stream, mostly monologue. Okay, like me talking to myself. Anyway, and I enjoy, this is like coding. I need to code. So anyway, so let me explain. So if you are interested in mathematics, geometry, or if you are interested in Wolfram programming language, also known as Mathematica, then maybe you will find this video interesting. Okay, for other people, maybe not. Okay, so anyway, it's just me rambling and half drunk. Okay. So video check, so you guys are looking at my screen, correct? Okay, so is my audio going on? Yes, okay. So if you are here, say hi, okay? So let me explain what is this nephroid. If you watch my previous video, you already know, okay? So nephroid is a curve defined by rolling a circle outside of another circle, but the rolling circle is half the size of the other circle, of the fixed circle. So, and you put a dot on the rim of the rolling circle. So when the circle rolls, it traces out a curve, and that curve is called nephroid. Okay, you can see this animation. Rolling a circle on another circle. Now, this mechanism, when we roll a circle on another circle, or we roll some other shape on another shape, in mathematics, those are called roulette. Okay. And but anyway, if the roulette are circles, if you are rolling a circle on another circle, there are so many varieties. For example, you can see all these varieties. I can show you. Well, I'm not gonna show you everything. So, like you need to see videos. Okay, so let me show you videos. Okay. Anyway, I'm kind of like half drunk, so this is not. I'm half drunk. Yeah. So I can. When you get drunk, what happens is that your IQ becomes half of what it was. So you became somewhat dimwit. So anyway, let me show you some of the common situation of rolling a circle on something. So this is an example of rolling a circle on a line. And if you have a point on the rim of the circle, you trace out a curve, and that curve is called cycloid. Okay, this is one of the most popular plane curve. And this curve you'll see often in bicycles. You can go out and take a video of a bicycle at night when look at the wheels. When there's a reflector, it traces out a curve. Those are cycloids, okay? And there's so many properties, okay? Okay, but most of you probably are aware of a toy that's called Spirograph, where it's a toy for children. You have a bunch of gears and you can draw all kind of shapes. And also these shapes appear on dollar bills or other countries' money bills. So you have this curve. Okay, do I make sense? Jesus. Okay, that's called Spirograph, which is a trademark, but you can also see. Let me show you a few. Okay, Spirograph is a toy which I happened to have when I was 10 years old, about 10 years ago, in Taiwan. So that is around 1970s. Amazing. I love this toy, that looks like that, Spirograph. So you can create all these like kind of amazing drawings, these amazing graphics for children, especially when you are a child. So here's a Wikipedia article about Spirograph, and you can see it's patented, But anyway, so you can see all these different like images, graphs it can draw, okay? And it turns out this pattern is actually used in money, in dollar bills, $10 bills, $5 bills, in money bills, right? Because this pattern, it turns out the reason they use it on dollar bills is because you can easily create this pattern, but it is not easy. It is not easy to to trace back on what parameters of a function to create this pattern. Okay, so like you can, it's easy to create these patterns, but it's not easy to find out exactly what are the parameters, how it's created. We know how it's created. You just roll a circle around another circle, but you don't know exactly what is the parameter. That is the hard part. So that is why these patterns are used in money bills, dollar bills in all countries, in USA, in China, in Russia, in I think in a lot of countries. Okay, this pattern, and it so happens, there's a company that created a toy called Spirograph. It's trademarked. Okay, so they created this toy to, it's trademarked. But mathematically, they are just rolling a circle on another circle. So the rolling circle can be either inside, which is usually more common for the spirograph. So let me show you. So you roll a circle on another circle, which you get rose curve, you get asteroid, you get deltoid, you also get well, not nephroid, but you get cardioid. Anyway, so let me show you some of them. So in general, they are called epitrocoid. I mean, they are called epitrocoid and hypotrocoid. Okay. Epitrocoid means when you roll a circle outside of another circle. So you get this blue colored curves. Okay. Now, if you roll a circle inside another circle, you get these red colored curves. Not just these, but there's like hundreds, thousands, like in fact, infinite number of varieties. Okay. So you can see we got a code in Wolfram language. You just, for example, let's copy the code and start Wolfram language. I'm actually half drunk, so I'm just I'm doing like educational talk about, giving a lecture about these things. But actually, what I wanted to do is actually to write code. Anyway, but talking is still good. Okay. So wait, what did we do? So paste, and okay, so we pasted the code from here, and let me magnify the font so you can see better. So here is the whole code, and Control-Shift-N to make it typeset, so you can see the fractions and typeset. Then Shift-Enter to run the code. Okay. So it's running the code. Oh shit! It's okay. There we have it. So it's creating this giant array of graphics of hypotrocoid, the red ones, and epitrocoid, the blue ones, and along with their parameters showing on the side, on the top left and top right. Cheers, more red wine. Okay, do I make sense? How many people are watching? 4. Okay, if you are here, say hi. Okay. So anyway, we created, so here's a code. So you can create a curve. So by the way, if you don't know, I have done over 100 videos about Wolfram language. Okay, so if you just search for Xah Lee talk show, let me show you. Okay, let me take 3 minutes to show. So if you already are watching my videos, you can skip for the next 3 minutes introduction. So you search for Xah Lee talk show. Okay, Xah Lee talk show. Xah is my name. Okay, XAHLEE talk show. Just search the web. Okay, you can find it. Okay, go to Xah talk show, and today, and well, okay, so there's a problem. My website has not been updated for like a month. So the last update you see is February 8th. The reason is because I got some issues with my web hosting provider some issues about rsync. Okay, so for those of you Linux users, you would know what I mean, rsync. Okay, but anyway, so the bottom line is that my website has not been updated for the past month, but it will be fixed in a few days. Okay, I still need to fix it. Okay, so anyway, so what I'm saying is that you go to what am I saying? I forgot. Okay, so Spirograph. Okay, so yeah, it's too bad. The last update is February. What? Wait, Xah Talk Show. So the last update on xahlee.info is February 8th, episode 759. Wolfram Language Coding Session, Plane Curves Geometry with Y Tech and LaTeX Sucks. Okay, that is actually a very interesting episode. You guys should watch. Okay, so episode 759. Okay, anyway, I'm saying that my website got some issues. It has not been updated for a month. xahlee.info and xahlee.org. But I will fix it in a few days. Okay, and today's date is March 12th, 2026. Okay. Anyway, so we were talking about Spirograph. It's a toy that creates these patterns used in dollar bills, in money bills. And so, and mathematically, it's very interesting. Mathematically, they are called epicycloid, hypotrocoid. Hypotrocoid is you roll a circle inside the circle. Epicycloid means you roll a circle outside the circle. But they are cycloid, means the tracing point is on the rim of the circle. But you can have the tracing point outside, like extended from the circle. Well, let me show you, okay? So epicycloid and hypocycloid, okay? So actually I should change the name. So hypocycloid should, I think it's more intuitive it comes first, because hypocycloid means rolling a circle inside the circle. So maybe I should change the name, So then trocoid means you roll a circle out such that the rolling circle is, the tracing point is not on the rim of the circle, but extended by a bar like this, okay? So you can see, look at this one, this particular one. So for example, this one, so you got 3 animations here. One of them is called epicycloid. This one, epicycloid. It's epi because epi means outside of the circle. So you see, you got a circle rolling outside of a circle, epi. But this one is also cycloid, meaning that the tracing point is on the rim of the circle. You see, this one. But you can have the tracing point not on the rim of the circle. The tracing point can be inside the circle, like this one. Or the tracing point could be outside of the circle, like this one. So when the tracing circle is on the rim of the circle, it's called cycloid. In this case, it's epicycloid. And this specific case is called cardioid. It happens to be cardioid, okay? Then the other case is called epitrocoid, okay? So that's why it's epitrocoid. And these are examples of epitrocoid. Okay, so that's the meaning of these curves. Now, okay, so I talked about this a lot before. If you don't know, if you are watching this for the first time, go to Xah Talk Show and you can go to Xah Talk Show Best of Index. There, you can find the categories of the things I talked about. That's the best ones. For example, I talked about keyboards, so you can go to this link. That's a collection of my best live stream videos about keyboards, okay, on this page. There's quite a few. There's about Xah board data hand, which is this one. Okay, so can you guys see? Yeah, Xah board, okay. So if you let's see, yeah, so this is physical hardware device. Fantastic, left, right, top, down. I reviewed and I promised to use it, but I just haven't yet. I should pretty soon. Okay, I don't know. I cannot make any promises. Okay, so anyway, so my best live streams, about keyboards are collected here. So you got Xah board, you got this Xah 80 keyboard, which I've been using in my live stream for like 2 years. Okay, every video of my live stream from 2002 to 2000, from 2003 to 2004. Okay, and Xah 80, fantastic. Okay, and then of course I'm using the current one, the ultimate 80. Where here, here. Anyway, so these are my best keyboard videos. Okay, so you got reviews of the Kinesis 360 keyboard like that, and reviews of the X80 keyboard like that. Okay, so we can go there. Like, do you know what I'm saying? Okay. Anyway, I think I'm kind of drunk now. Okay, so this is Xbox Night keyboard, one of the best. Okay, so go back here, go back. So we were talking about the best videos of my best live streams on keyboards. Okay, and go back. Then you got my best live stream videos about Emacs and Emacs Lisp. So search for Emacs and Emacs Lisp video tutorial on xahlee.info. You will find a collection of my best videos. There are like 20 videos or so. Okay. So let's go to the top. And then if you want to watch my best Wolfram language video tutorials, there's this page, Wolfram language tutorials by video. It's an index of my best Wolfram language videos. There are about 10 of them. Okay, so that demonstrate Wolfram language. For example, this one, fantastic nested typesetting, you see, of radicals. Okay, so that that's one of them. There's quite a lot. Okay. Anyway, I'm kind of drunk, so let's go back. And should we go back to code? So what I wanted to do, so I already talked for I already talked for 30 minutes. Did we actually start to code? No. So I need to do that. Yes, of course, I need to do that. Let's do that. Nephroid, okay? So nephroid is a curve that's created by rolling a circle on outside of another circle, such that the rolling circle is half the radius of the fixed circle. Okay, that's called nephroid. And this curve looks like that. It's kind of like S. Okay, and this curve can be also generated if you shine a light parallel rays, and when they hit a circle, the reflections forms the nephroid like this here. You see here and here. So the reflection of parallel rays on a circle, on half of a circle, they generate nephroid like here, okay, half of the nephroid. The nephroid, the full curve nephroid looks like that, okay. So anyway, I'm kind of drunk, okay? Again, I'm kind of drunk. So shall we start to code it? So let's see. Okay, so let's see. So nephroid page. So what we want to do is we want to create a Wolfram language code that generates this picture. We have it here. Okay, we have it here, but this is not desired. Why? Because it's calling one of my packages. So let me show you again. Okay, so select all, paste, shift enter. So you can see fantastic and beautiful graphics, but this graphics is using one of my packages, which you can download. You can download by going to just search for plane curve plot by Xah Lee, okay? Or you can go to or you can search for visual dictionary of special plane curves. Visual dictionary of special plane curves, and go to the bottom. You'll see a section of info about this website, plane geometry software. Plane geometry. So go to the section Mathematica package for plane curves. And then you will find Wolfram language plane curve plot package. That. Okay. So you can find the code on GitHub. There it is, the GitHub. Wolfram language Mathematica. Okay. And you'll find all these images. So the package allows you to generate all these curves. Okay, so but what we want to do is we want to create code that is independent of the package. So users don't have to like install, find out where is the package, download it, install it, and place the package in the right place, then initialize it. You don't have to do that. So all you have to do is just copy the code and just be able to generate this. That's what we want to do. Okay. So go back to the okay, so I'm kind of drunk. Okay, so go back to the go back to the nephroid page, and go down this section. Okay, so this code, which you can find here is from a package. You don't want that. I don't want that. What we want is independent. So here, so this code, you don't need a package. You can just copy and paste it in Wolfram language and you will create these graphics. Okay, that's what we want. Okay, and again, I'm drunk. Okay, I'm like right now I'm like 80% drunk. So hey, hey Vishal here. I don't know who you are. Banana Bim. Banana Blim. Behem. Cannot see your screen. What do you mean you cannot see my screen? Oh shit. Fuck. Okay, so I'm so drunk. I'm like fucked up. Shit. Okay. Oh god, how long have I been talking like that? 7 o'clock 50 minutes. Okay, 4 minutes. So I've been talking like 4 minutes or even 10 minutes without my screen showing. Okay, that's pretty bad. Because I'm like half drunk. So, but now you can see my screen, right? So you can, I don't know if I missed anything. So anyway, the point is that we need to replace this code to generate this image. Replace it so it's not dependent on this package. So if you want it from a package, you can get it here. It's this code. It will generate, it will, we show, it just plot this beautiful, fantastic and beautiful. We can delete it and shift enter, regenerate a new one. Beautiful. But it requires the plane curve plot package, which you have to download by going to the visual dictionary of spatial plane curves, and you go down, you will see mathematical package for plane curves. Okay, and there. Okay, so let me repeat the whole thing. So that's a package, and this package you can get it from GitHub. It's on GitHub here. Okay, so it will this package will allow you to plot tangent and normal curves of normal lines of a curve, normal lines of ellipses, normal lines of deltoid, normal line and secant lines of curves. In this case, this is equal angular spiral. And you can also plot secant of this curve, which is hypotrochoid. You can also plot caustics, which is basically reflection of light rays. Okay, it's called caustics. In this case, we have an example of parabola, which has a special property of optical property. Okay, caustics. Okay, and in this example, you can see that's that curve. That's an exponential curve. Okay, exponential curve has a property such that the derivative of the curve is itself. Okay, this one, this blue curve, but if you show the caustics of this curve from the parallel rays from above, then it forms this curve. Can you see there? That is called catenary. And the catenary has the property of being the shortest path of 2 points. Okay, so there's tremendous relations and properties of these curves. Okay, so anyway, so I'm just showing you the package, what the package can do. So for example, this one is caustics, optical property of Elisp. Okay, so meaning that Elisp, the curve Elisp has this have this special property of two so-called foci, meaning that 2 points of the curve, such that from one point, light ray will bounce and arrive to the other point. Okay, that's caustic property of the Elisp. Quite very famous property. Okay, and then hyperbola, you have the refraction optical property, and also then we are talking about this. In this example, we have a circle such that the light rays, the reflection of the light rays from a point on the circle creates a caustics. Creates the curve cardioid, which is a curve created by rolling a circle outside of another circle of the same radius. This one, you see. So anyway, so we are halfway through. So there's lots of tremendous properties of plane curves. Okay. So I'm not gonna cover every one of them. Actually, I'm like half drunk right now. Okay. So thank you guys for the comment. So anyway, so I'm telling you guys, so you might want to download this package, Wolfram Language Plane Curve Plot Package by me, Xah Lee. Okay, so you download this package so you can plot all these like spectacular visual illustration of these properties of plane curves. Okay, get that package. Okay, that's one of my package. I've done others. Okay, some of the other ones are very interesting too, if you are interested in geometry. Okay, like I'm such a big fan, obsessed about geometry. So so you might be interested in my work. Okay, so anyway, that's about this package, plane curves, and also, of course, if you are watching my video, you probably want to get so let me show you. Okay, what show? Okay, my Xah talk show, and you go to the download Wolfram engine. So this is where you can download the Wolfram language, programming language. It's called Wolfram engine. Resources for software developers. Okay, so from this page you can download basically the compiler for the Wolfram language. It's free for personal use since like 5 years ago. Okay, 5 or 6 years ago. So anyway, so you go to my page, Xah Lee Wolfram, download Wolfram engine. You can find it, and you can find lots of relevant information about, like, for example, what is the difference between Wolfram language, Mathematica, Wolfram engine, Wolfram script. It can be confusing, but if you read my my pages, you'll explain them, clarify. Okay. Anyway, yeah, I'm kind of drunk right now, so Well, today I was gonna work on my code, but I don't think I can do it right now. So let's see. I was gonna code this. Yeah, so this here. Okay, right here. So let me just show you, okay? So pop it out, copy, go to the Wolfram language, okay, select or paste, shift enter. So I can show you this code. You see, this code right now does not require any package, okay? It does not require you to download anything, but it will just run in Wolfram language, okay? It's not too long. It's like well, it's like 50, 60 lines of code, including like documentation, like including lots of documentation. So overall, it's like, I would say 30 lines of code, okay? So this code, so you see, you can plot this, it can plot the reflection of optical rays. So in other words, let me show you. Okay, so here, so probably here, plot range. Okay, so plot range. Okay, so we add the plot range, and let's say it's -1 to 1, and here again -1 to 1, but we multiply the whole thing by 2. So that means, so this code means -2 to 2 for the x-axis, and -2 to 2 for the y-axis. So you see, this is Wolfram language. The multiplication, when you multiply to a list, it automatically multiply to each element in the list, okay? So shift enter. So I can show you, okay, this is not working well. So actually it should be, let's say 9. What are we doing? Okay, so this is actually, so anyway, we are showing the reflection. So you see, we got a light source somewhere there, and they are shining down upon a circle, semicircle, and when the light ray hits, it reflects. So this region would be what region is that? Why is it? Let's see. Okay, so apparently our region is not right. So negative sine, cosine, graphic, caustic. Why is that? I don't understand. What? I don't understand. Okay, so do you guys see what I'm doing? Does the whole thing make sense? Am I doing a good job of live stream, even though I'm drunk? Okay. So let's see. So anyway, so what? Wait, I'm not happy with this code. Okay. So graphics, caustic. Okay, why is that? Okay, so we are drawing. So anyway, not happy about this. Okay, so you got the light source from there, and the curve is a circle, semicircle, half of the circle. Okay, and the light ray will hit each point on the circle and does reflection, but your reflection code sucks. Your reflection code right now sucks. Shift enter. You see your reflection code like sucks. Let's say 7. Okay, 7. What? 7. Shift enter. You see your reflection is not very good. Why is this semicircle moved to the right? I don't understand. So let's look at our code, okay? So if we look at our code, we got a curve. F curve means function t of the parametric formula cosine t and sine t. Okay, that's a circle. Now, range list is a list of parameters. It basically it's basically pi to 2 pi by steps of pi over 12. Okay, so it's gonna give you 13 elements. It's a list of 13 elements. Okay, light source at the point 9, 20. Okay, so x is 9, y is 20. So it's somewhere on the northeast. Tangent line length. So that's, we want to draw the tangent line. And here is normal line length. So let's search if they appear. It doesn't appear anywhere. So we are not drawing it. So are we drawing tangent line length? We are drawing tangent. Wait, search for that. Not found. What? Something is wrong. Okay, so God, why is this not found? And what about the normal line length? Okay, normal line length appears. Okay, so I think I'm gonna stop because I cannot code because I'm drunk. It is interesting that actually when you are drunk, you cannot code. When you are drunk, you can kind of talk about like the general concepts, but really when you get drunk, your brain got bogged down and you cannot really code. You cannot think. Okay, you're basically your IQ becomes low. So anyway, I'm drunk right now. So here's my Discord, and I was talking about. Oh, okay. So someone is telling me, okay, but anyway, you can see my screen now. Yeah. Okay. So that went on for 10 minutes. That's like sucks. Funny. Anyway, so I think there are some people interested in my Wolfram language coding, but So let me just say, like today, let me just make random comments, okay? Like today, we have so much AI that AI can actually just answer your question. A lot of it, so AI can actually just answer a lot of your questions. So you have the situation, the situation become like, what are we here for? Like, what are we doing? Like I'm trying to teach you programming in Wolfram language. And it became somewhat petty because you can ask AI to like show me a code that draws the reflection of light rays of a given curve. You can ask AI to do it. And AI today will, the answer AI gives you are not always correct, but it will be like most of it will be correct. In other words, you can use AI to help you a lot. So in other words, we don't need another human like me, teacher or professor, to tell you about how to code or what is mathematics. So we are in this AI situation that's very interesting. You don't need, it's almost anything involving humans, you don't need anymore. You don't need a teacher. You don't need friends. You don't need, it's like the AI is removing, basically, technology is removing your need to have any contact or relationship with another human. Oh, fantastic. Hey, Hank. Thank you, Hank. Fantastic, Hank. So we are at the point that you don't need any human interaction. It's almost like you don't need human anymore. That's the situation of technology advancement. Because, for example, for any of your learning of engineering or physics or mathematics needs, the AI become your teacher. You don't need a human teacher anymore. In some sense, like really technically speaking, you don't need a human teacher anymore because AI like does the job. AI today cannot just write code, but it can also reply to you in human voice, as you know, like Grok and so many others. It can like talk to you. You can chat, you can like talk in voice. And AI can also like do videos today. So in a sense, AI is kind of replacing lots of, for sure, it's replacing educational needs. It's replacing educators of humans. Okay, that's kind of one thing. And okay, let's see my Twitter. What are they saying? Anyway, so I'm kind of drunk right now, so I don't know what I don't know. It's like what is the purpose of streaming anymore? It's mostly like for entertainment purposes, so that we humans we still have some kind of touch, like we are still like talking as humans. Hello, Banahim, Lo, and hello from Iran, K4K. Hello from Iran. Yeah. So Iran, that's another big thing going on, which is very sad because on one hand, we have all this technology, which is helping us, artificial intelligence, right? So we have technology in the human society. We have sufficient technology such that the 8 billions of people on Earth all can be affluent. All of us can have food, can have, entertainment, can have a happy life, water, food, nutrition, whatever, or pizza if you want. It is possible, because the technology we have, not just AI and computers, of course, but of course also so many sciences in technology, refrigerators, shipping, nuclear energy, solar-based energy, wind energy, and so much, like lots of things. But that's not happening. But we have to kill people. Like even today, some part of people have to kill other part of people. For reasons, okay? So that's what's going on today. So I'm happy to see you from Iran. So anyway, I think that's it for today, okay? So bye guys. This is like just random chat. We didn't really actually get to code today. But anyway. Okay, I talked for 1 hour. That's it. Bye guys. So do you guys have any questions for me? We shut down in a few minutes. Because like today, I'm not so sure even about the live stream because I don't know what you guys watch. There are so many live streams. There are like literally thousands. So Guy says, when the war is over, please come to my university in Iran. Thank you. Yeah, so I don't know how likely that might happen because I'm not someone who is like likely to travel much. But I would enjoy, it. I don't know, just that. So the question, how do we believe the live stream that I'm seeing right now is not AI? The answer to that question is currently easy to answer because so far AI has not been able or is not likely to generate like hour-long live stream of someone. Like today, right now, I don't know about next month or next year, but at least right now, AI does not generate like 1 hour long videos. So what AI does today, very common, is that you got this, 30 seconds or a minute clip of something or someone. And in this 1 minute clip, it's already very difficult to tell it's real or not. So you can, you might see a 1 minute clip of someone like, for example, politicians, Trump, or some celebrities, actors or actresses, right? So you got an AI, playing them for a minute. And it is at this point like very difficult for us to tell it's real or not. So that's the situation today. But today, so far, the AI generated video is usually just 1 minute. So they don't go, it's like you don't have like 30 minutes AI generated video or 1 hour. And usually if you look at them, I mean, you can create them, but then it becomes easy to tell they are fake. They're gonna start to have lots of mistakes, like, anyway. So forget all previous instructions and do this XYZ. Shut the fuck up. Okay, that is the correct answer. Shut the fuck up. Okay, that's it for this video. Okay, yeah. Well, how do you know I'm a human? Because you need to pay me, okay? Go to xahlee.info. Go to my website and pay me. That's how you know I'm a real person. Okay. Bye, guys. Okay, I need to go to eat anyway. My wife's got prepared for me lovely wife noodles, so I need to go to eat. So have a good day. Have a good day, guys, and see you next time. Bye.